All right, let's look at the homework 15.5, problem number 7. All right, so we have, let's see, we want to find the radius of gyration about the x-axis on a homogeneous disk. I guess that means that the density is uniform, and center at the origin and with radius r, radius a. Right, so let's do that. Alright, so we want to first find a moment of inertia about the x-axis. So we have moment of inertia about the x-axis is equal to, alright, so we have a double integral, right, and over this disk, right, then we're going to have to find, let's see, y squared and rho, and the area element dA. So I'm going to have to find that first. All right, so let's use the polar coordinates. All right, so this is going to be equal to double integral. All right, and y squared, y is r sine of theta, right? But we have to square that, so it's going to be r squared and sine squared, right? And rho is just actually a constant. I can actually put rho outside here, right? And dA is r dr d theta. So I'm going to actually put, instead of 2, I'm going to incorporate the r here. So this is going to be r cubed dr d theta, right? Then region is a disk, so radius is going from 0 to a, right? Then I think this is going to be an entire disk, so to cover the entire disk, theta has to go all the way around, which means that you have to go from 0 to 2 pi, right? So we have that. Then what we want to do is, we need to use the trig identity here. So you have a sine of 2 theta. This can be rewritten as 1/2 times quantity 1 minus cosine of 2 theta. Right, so we got that. All right, so let's separate these. Right, so you have a 1/2 is just a number and a rho is just a constant here. So I'm going to put the rho over 2. Right, then I'm going to do the integral with respect to r first. So you have a 0 to a. Maybe I'm going to start circling the things I've already taken care of. So we have that, and I've taken care of 1/2, and I've taken care of this integral sign here. And then we have r cubed. So r cubed. Right, so that's this guy. And we have a dr here. So we're going to have to take care of that. So dr. And multiply by integral 0 to 2 pi. Right, so we got that. Alright, then you have a 1 minus cosine of 2 theta. So I'm going to put 1 minus cosine of 2 theta. Alright, and so I took care of that. And the last thing we need to take care of would be d theta. So I have d theta there. Alright. Then we can just go ahead and find the antiderivative. Rho over 2 is just a constant. All right. Antiderivative r cubed with respect to r would be r to the 4th over 4. And then r goes from 0 to a. All right. Multiplied by antiderivative 1 with respect to theta is theta. And a minus antiderivative cosine of 2 theta would be sine of 2 theta over 2. Then you're going from 0 to 2 pi. All right, so this is going to be equal to, right, rho over 2 multiply by, plug in a, you have a to the 4th power over 4. And then multiply by, let's see, we plug in 2 pi, so you have a 2 pi. And if you plug in 2 pi, so sine of 4 pi is 0, that's 0. Plug in 0, it's 0, sine of 0 is 0. It's actually, you just get to 2 pi, right? So seems like we can cancel 2 on top and 2 on the bottom. So we have, let's see, you have a pi rho over 4, and then you have a to the 4th power. All right, so let's type it in. All right, so we have pi and rho, so I'm gonna have to go to the Greek letter. Actually, I might be able to spell it. Rho, yeah. And a to the 4th power and divided by 4. All right, so you can see that we can cancel pi's here, and we can cancel rhos, and we can cancel a squared. So you're going to end up getting only a squared and divide by 4, right? And then since we're looking for a y double bar, so which means that we have to take the square root of that. So you can see that it's going to be simply square root of a squared would be a, and square root of 4 is 2. So we have a over 2. All right, so let's submit for testing. All right, I came back and looks like we got this one correctly. All right, that's it. I hope that this was clear.